So, there is a general theory of test generation, okay, that let us revise that. Okay. So, suppose I have a circuit, a combinational circuit, okay, and let us say it produces it is a function of some of these inputs, let us say A, B, C, etc. Remember how a combinational circuit works. The output F can be produced as soon as A, B and C become available. Okay. So, there is no sequencing, there is no clock, there is no memory. So, as soon as you present A, B and C, the output F gets generated, right. Now, there could be a fault in this circuit. So, this is a good circuit and we could also have a faulty circuit. It could be anywhere, it could be a stuck at fault, it could be a bridge fault, it could be any fault. Okay. So, this will produce a different output hopefully. Okay. So, it will produce F prime of ABC. Okay. Now, when do we say that we have detected the fault? What inputs should I apply at ABC to detect the fault? So, that is what it is all about, right. So, I need to figure out what inputs must be applied at A, B and C, so that the good circuit produces a different output than the faulty circuit. Okay. If the good circuit and the faulty circuit produce the same output, then I will not be able to test. Okay. So, the good and faulty circuits must produce different outputs. Okay. When a test is applied at ABC. Okay. So, that is a basic idea. Okay. We say that a test vector detects a particular fault in the circuit if the good circuit and the faulty circuit, they produce different values. So, if this is producing a 1, this will produce a 0. If this is producing a 0, this will produce a 1, right. So, another way of saying the same thing is, if we put an exclusive OR gate here, okay, it is a fictitious gate. Okay. If these two guys are going to be different, okay, remember how the XOR gate works. In an XOR gate, if the two inputs are different, let us say 0 1 or 1 0, the output is a 1. Okay. So, F exclusive OR with F prime is 1. So, this is the condition for a test. Okay. We say that ABC, a test vector applied at ABC must satisfy this property, F exclusive or F prime is equal to 1. Okay. So, let me illustrate this. So, let us take a very simple circuit. So, let us take a trivial circuit, an AND gate. So, this produces a good circuit will produce A B whole bar. Okay. Let us take a faulty circuit in which B is stuck at 1. So, if B is stuck at 1, this circuit will produce A bar. Okay. So, B is 1, so A dot B whole bar will become A bar. Okay. So, this is my F and this is my F prime. So, I can put an exclusive OR gate here and insist that this must be 1. Okay. So, in other words, AB whole bar XORed with B bar, I am sorry, XORed with A bar should be equal to 1. So, under what conditions will that be true? Okay. So, you can if you want simplify this, there may be more than one way of doing this, right. So, let us try it the usual way, AB whole bar. If you remember, X XORed with Y is same as X Y bar plus X bar Y. So, we will use this idea. So, we have AB whole bar dot A bar whole bar is A plus AB whole bar is AB dot A bar. So, this should be equal to 1. Okay. So, this becomes 0, okay, and this becomes A bar plus B bar. We will use De Morgan's theorem. So, A bar plus A B bar, okay, A bar will become 0. So, we are left with A B bar equals 1. So, this means we must apply A equal to 1 and B equal to 0. Okay. So, if you take the NAND gate, okay, a good circuit will produce a 1, okay, whereas if this was stuck at 1, the faulty circuit will produce a 0. Okay. So, this is a notation that we will use. Okay. If you write 1/0, it means the good circuit produces a 1, a faulty circuit produces a 0. Here also we can write 1/1, which means both the good and the bad circuit or the faulty circuit have a 1. Here we can write 1/0. Okay. So, 1/0 means a good circuit has a 1, but a faulty circuit has a 0. I am sorry, the other way around. My apologies. A good circuit has a 0, but a faulty circuit has a 1. Okay. Because we are looking at the B stuck at 1 fault. Okay. So, if you simulate, a good circuit will take 1 and 0 and produce a 1. A faulty circuit will take a 1 and a 1 and produce a 0. Okay. So, this is an important notation that all of us need to remember, right. It will become useful to me later, right. So, let me give you one more example. Okay. Let us take a little more complex example. Okay. Let us take this circuit. The good circuit's output is AB whole bar plus C plus D whole bar. Okay. So, AB whole bar is available here, C plus D whole bar is available here, and G is the NOR of these two guys. And if there is a AND bridge between the two, okay, then the circuit will produce, remember there will be a fictitious AND gate in an AND bridge, and that is getting, so this is a faulty circuit with a bridge fault E bridge F. Sometimes we write like this, E bridge with F means there is a short circuit between the two. Okay, this is an AND bridge. Okay. So what will happen to the output here? This AND gate will produce AB whole bar dot C plus D whole bar, right? And that whole thing is inverted here. Okay. So the test vector that I must apply at ABCD should cause G exclusive OR with G prime should be 1. Okay. So let us simplify G a little bit. So what is this actually? This is of the form x bar plus y bar bar. So this is nothing but x dot y. Okay. Because x bar plus y bar is xy whole bar. Okay. We can write x bar plus y bar is xy whole bar, and that is xy. So here x is AB and y is, I believe, C plus D. In the same way, G prime is of the form x bar dot y bar bar. Right. So this is of the form x plus y. Okay. X bar dot y bar is nothing but x plus y whole bar, and that whole thing is inverted. So this is of the form x plus y. So this is nothing but AB dot C plus D. I'm sorry, I think I made a mistake here. Let me just correct it. See, I should have written x dot y. So this should be x a dot b plus. Okay. So here it is AB plus C plus D. Okay. So once again, AB whole bar plus C plus D whole bar. I have written AB whole bar as x bar, C plus D whole bar as y bar, and this inversion is written here. So x bar plus y bar whole bar is x dot y. So this is x and this is y, and the same thing is true here. So now a test for E bridge with F, okay, will cause this property. That means AB dot C plus D XORed with AB plus C plus D should be equal to 1. Okay. So of course we can go ahead and expand all this, right, and then try to find values of A, B, C, D, which will result in. So we have to make sure that these two are different. If this is 0, we should make sure that this is 1, or if this is 1, we should make sure that this is 0. Okay. If you want, let us try doing it like that. Let us see if we can make AB dot C plus D to be 1. So, for that A must be 1, B must be 1, and then C plus D is equal to 1. So, let me try C equal to 1 and D equal to 0. So, this will make this 1. Okay. Unfortunately, if I do that, what will happen is this will become AB is already 1. So, this will also become 1. So, this will not work. Okay. So, this will not work. Let us try to make this let us try to make this 0 guy. Okay. So, let us try A equal to 0 and B equal to also let us say 1 maybe. Okay. And C and D also are let us say 0. Okay. But this will also become 0, isn't it? A dot B, right? A dot B will become 0 and plus C plus D is also 0. We can now try A equal to 0, B equal to 1 and maybe C equal to 1 and D equal to 0. That will result in A is 0. So, the whole thing will become 0. Okay. A is 0. So, the whole thing will become 0. So, on the other side we have A dot B is 0, but because C is 1, this will become 1. So, this may work. So, we should have A B to be either A or B to be 0. So, this is a test vector. Okay. So, you can verify. Okay. Let me try to do it in a different color here. So, I have applied 0 1 1 0. So, a good circuit will produce a 1 here and a 0 here, and as a result this will produce a 0 here. Okay. Now, let us try applying 0 1 1 0 and a good circuit will produce a 1 here, a 0 here, it will produce a 0 here and it will produce a 1 here. So, you can see that this particular 0 1 1 0, okay, we say 0 1 1 0 is a test vector for E bridge with F.